Hello viewers, in today's class we are going to discuss one important problem from three-dimensional geometry, right? So here we are going to take up one important conceptual problem from the topic, that is intersection of lines, right? So here we are given a problem in which we have to show that these two lines do not intersect each other, right? So here what we are given, the equations of two lines, right? And we have to tell that these two lines do not intersect each other, right? So let us try to solve this problem, and here we can take two methods to solve this problem, but we'll do it by only one method, right? So the first method is that is the shortest distance method, and the second method is the general point method, right? So here we will not solve this problem by method of shortest distance, but we will solve it by method of general point. So in the method of general point, what we will do, right? So first we will write these equations of these two lines. Write L1 as x minus 1 over 3 is equal to y plus 1 over 2 is equal to z minus 1 over 5, and L2 as x plus 2 divided by 4 is equal to y minus 1 over 3 is equal to z plus 1 over minus 2, right? So first we will write these equations like this, and here we'll take two scalars, say lambda and mu, right? So lambda and mu are two scalars which are used to find out the coordinates of the general point lying on these two lines, right? So suppose that this is the line L1 and this is the line L2, right? And we'll try to find the coordinates of the general point lying on this line L1, which is say P, and the general point lying on this line L2, say this is point Q, right? So now let us first take this line L1, right? So x minus 1 over 3 is equal to y plus 1 over 2 is equal to z minus 1 over 5 is equal to lambda, right? So we can form three equations from here. See, first one is x minus 1 over 3 is equal to lambda, then y plus 1 over 2 is equal to lambda, and z minus 1 over 5 is equal to lambda, right? So now we can rearrange these equations. So x is 3 lambda plus 1, y is 2 lambda minus 1, and z is 5 lambda plus 1, right? So here in the line L1, the coordinates of the general point in terms of lambda are given by 3 lambda plus 1, then we have 2 lambda minus 1, and then we have 5 lambda plus 1, right? Okay, now similarly let us find out the coordinates of the general point Q lying on this line L2. So now similarly we can write here x plus 2 over 4 is equal to mu, y minus 1 over 3 is equal to mu, z plus 1 over minus 2 is equal to mu, right? So let us arrange these equations. So we have x is equal to 4 mu minus 2, and here y is 3 mu plus 1, and here z is equal to minus 2 mu minus 1, right? So now the coordinates of this point Q can be given by 4 mu minus 2, then we have 3 mu plus 1 and minus 2 mu minus 1, right? So now we have obtained the coordinates of the general point P and Q lying respectively on these two lines L1 and L2, right? Okay, so the next step is to form equations in lambda and mu, right? So now if this line L1 and L2 do not intersect each other, then it implies that P and Q should be different, right, for some value of lambda and mu, right? So what we will do in order to prove that P and Q points have different coordinates, first we will assume the contrary, right? So what we will do, we'll solve it by a method of contradiction. Let us first see or let us first assume that this line L1 and L2 do intersect, right? So if these two lines intersect, then what happens, this point P and this point Q must coincide with each other, right? So when P and Q coincide with each other, in the case of L1 and L2 are intersecting, then these two coordinates must be equal, right? So what does it mean? It means in order to prove that these two lines do not intersect each other, first we will assume that these two lines do intersect each other, right? So when these two lines intersect each other, it means P and Q represent the same point, right? So when these 2 points represent the same point, it means 3 lambda plus 1 must be equal to 4 mu minus 2, because the x coordinates must be equal. Similarly, the y coordinates must be equal and the z coordinates must be equal in case of intersection of these two lines, right? So first we will assume that these two lines intersect each other. So when these two lines intersect each other, it means again 2 lambda minus 1 must be equal to 3 mu plus 1, and then 5 lambda plus 1 is equal to minus 2 mu minus 1, right? So we have got here three equations, right? 1, 2 and 3. So now what we will do, we can take any two equations from these three equations and we'll solve it for lambda and mu, right? So if we take equation number 1 and equation number 2, right, and we'll find out the value of lambda and mu from these two equations, and then we'll substitute this value of lambda and mu in the third equation. Now if the third equation gets satisfied by these two values lambda and mu, then it implies that these two lines intersect each other, right? But if the values of lambda and mu do not satisfy this equation, it means L1 and L2 do not intersect each other. So let us solve these two equations, equation number 1 and 2. So let us rearrange them. So first we'll get 3 lambda minus 4 mu is equal to minus 3 from equation 1, and then from 2 we have 2 lambda minus 3 mu is equal to minus 2, right? So now we have these two linear equations in lambda and mu. So what we will do, we'll try to solve it by method of elimination, and we'll equate the coefficient of lambda in these two equations. So we'll multiply it by 2 and here we'll multiply it by 3. So we'll get 6 lambda minus 8 mu is equal to minus 6, and here we'll have 6 lambda minus 9 mu is equal to minus 6, right? So I think here we'll get the positive 2, because this minus 1 will go to the right hand side. So 1 plus 1 is 2. So here we'll have plus 6, right? Okay, so now we have these two equations. We'll subtract and we'll have 6 lambda and 6 lambda get cancelled. Here we'll have mu and here we'll have minus 12, right? Okay, so the value of mu is minus 12, and if we substitute it in equation number 1, that is this equation, so we'll get 3 lambda minus 4 times minus 12 is equal to minus 3. So this is 3 lambda plus 48 is equal to minus 3. So 3 lambda is equal to minus 3 minus 48, that is minus 51. So lambda is equal to minus 51 over 3. So lambda is minus 17, right? So the value of lambda is minus 17 and the value of mu is minus 12, right? So now we have obtained the value of lambda and mu, right, from these two equations. Now what we will do, we'll substitute these values in this equation, that is equation number 3, and we'll see whether these values satisfy this equation or not, right? So we'll get 5 times lambda is minus 17, then we have plus 1, here we have minus 2 times minus 12, and here we have minus 1. So this is minus 85 plus 1, this is 24 minus 1, so this is minus 84, and this is 23, right? And we easily see that this is not true, right? So we arrived at a false result here when we substitute lambda is equal to minus 17 and mu is equal to minus 12 in equation number 3, right? So hence this shows that these two lines L1 and L2 do not intersect each other. So whenever we have to show whether two lines intersect or do not intersect, what we usually do in the method of general point, we try to find out the coordinates of the general point lying on the two lines like this, and then we assume that these two lines intersect each other. It means these 2 points coincide, and we frame 3 equations, right? And we select any of the 2 equations to get the value of lambda and mu, and then we substitute these values in the third equation, right? And if the third equation gets satisfied, then we say that the two lines intersect, right? And if the third equation do not get satisfied by these values, then we say that the lines do not intersect, right? So viewers, this is the method of general point to show that whether lines intersect or not.